Okay, so let us first write a Verilog program for the full adder. Okay, so let us write Verilog program for 1 bit full adder. So 1 bit full adder. Okay, so let us write how do we write a Verilog program for this one. Okay, so it's very easy. First of all, we should know whenever we want to write a Verilog program for a particular digital circuit, first we should know what is the block diagram of that particular circuit. Okay, so as all of you know that what is the input size for this full adder. For example, it's a full adder. For example, FA means the full adder. So we have A is one input, B is one input, C is another input. Okay, A is one input, B, C is another input. It has got two outputs, as everybody knows that, sum output. Okay, sum, and the next one is carry, or I can simply write a C out. Okay, I will simply write C out. Okay, so if you want to write a gate level modeling, everybody knows that. Okay, so as I mentioned previously, so gate primitive statements are important. Gate primitive or gate level circuit is required, as simple as that. If you want to write a gate level modeling, gate level circuit is important. Gate level circuit is required. So from the digital electronics point of view, everybody knows that. Okay, so we have to develop the equations for the sum. Sum is equal to A exclusive B exclusive C, and C out is equal to AB plus BC plus CA. Everybody knows that one. Okay, so from this equation we can develop the hardware. Okay, so therefore what is the inside of this particular hardware? So that is based on these equations. Okay, so I'll write the circuit diagram here quickly. Something's happening. Okay, so here the 3 input AND gate is so 3 input XOR gate is required. It is called A, B, C, and 3 AND gates are required. So this is connected here, this is connected here, this is connected here, something like this. So it is actually, the first one is A, the second one is B. Okay, for the second one is B is connected here, and C is also connected here. For the third one, A is connected here, C is also connected here. So this is what actually we can see for this one. Okay, so right here. So these are nothing but A, B, C. This is some signal. This is called C out signal. Okay. Now, so this is what inside of the circuit, right? This is what inside of your circuit. I think it's better to know right colors here, so that it is very useful. Okay, fine. So therefore the gate level circuit is there in our hand. So we can write a Verilog program for this one very quickly. So please try to understand how to write a Verilog program in the gate level modeling. Okay. So in the previous class also we have seen that every gate level every Verilog programming is started with the module keyword, because we treat the black box as a module. So therefore I am going to write a module is the keyword, a lowercase letters we have to use. Okay, and let us give the name of this one. It's a user defined, so whatever the name that you can give, it's possible to give. Okay, I am writing interested to write FA, so underscore gate level, or I can write it gate level modeling is something like this. Gate level modeling, GL, gate level modeling. So for easy to understand or easy to recollect that name, for that reason I am using this way. Okay, so what is the external view of this one? I need to write here. Okay, those who are not able to understand previously, please try to understand now itself. Okay. So what is the variables that we are using for this external device? We are talking about this device. Okay, what is the external view that we are doing here? A is one variable, B variable, C variable, sum variable, and C out variable. Okay. So these are the different variables I am using. Okay, it's up to you. For example, A input, B input, C input, something also we can write it. But it is the easiest way that we can write the Verilog program. Okay. Next one is we need to define among these particular variables whether those are input variables or output variables. So we can understand here is that these are all input variables. So these are all output variables, right? So therefore I can define those things. So out of these variables, inputs are A, comma B, comma C, right? So we have to write the lowercase letters only because whatever the way that we write, for example, here if you write capital A, then only we have to write a capital A. We are allowed to write capital A. Otherwise, we should not write. Please remember the point. Okay? So it's a case sensitive. Verilog is a case sensitive. So as you can see that it's a small c that I have used. So small c only I have to use. We should not write a capital C. Okay? Please try to understand. The next one is an output. Okay. So outputs are nothing but sum and C out. Right? So this is the second step. So whatever the big circuit it is, whatever the large circuit it is, it doesn't matter. Just you have to identify that. You treat that as a black box. So you have to identify that what are the input signals, what are the variables you are using for the inputs, what are the variables you are using for the output. That's all. Okay. So and what is the internal to the circuits, that is depending upon what type of modeling style that you are using. Okay. So you are using the gate level circuit. You know that the gate level circuit is there in your hand. Therefore, gate level modeling is sufficient. So let me write the gate level modeling for this one. Okay, before going to write that one, so I better to write the numeric nature for each and every gate. So that is G1. Okay, it is not necessary, but it's better choice. G3, G4, G5. Okay. So we can directly call this exclusive OR gate into your main program with the help of keyword XOR. XOR is a keyword that is used for the exclusive OR gate. Okay. So what is the name that we have given? G1 we have given. So what are the variables that I should write here? So that means within this bracket we should mention what is the output first, what are the inputs that we are using for that particular gate. What are the outputs that we are writing here? What are the outputs that we are writing here? First, what is the first output? What is the output for that particular gate? G1 gate, sum. As you can see, sum is directly connected to that one. Okay. So therefore I can write sum is my output. So here you can see S is a capital letter that I have used for usual practice that I have written, but its best choice is you have to use those lowercase letters only. Sum, all are lowercase letters only. You please identify what I am doing here. Sum is a small letters only I am using. Next. So what is the input for this one? A is one input. Next B is one input. C is another input. Okay. So this is how we have to write Verilog program or gate level primitive statement. It is called a primitive statement. Right? It is called a primitive statement. Gate primitive statement for that one. Similarly, we have another gates are also available. So we write directly. If it is an AND gate means AND keyword that I have to use. The name of the gate is C2. Okay, so what are the variables I am using? So for if you are calling a particular gate as a primitive, okay, we should write first output, then we have to write inputs. You please remember this point. Okay, so for this particular gate, what is the output now? So is there any name for this particular gate, this particular Y? It is not directly connected to the output. It is internal to the circuit, right? So we did not mention any name for that one. So let us write the name of this one is T1 for example. Right? So therefore let us write here is a T1. Okay. Then what are the inputs for that one? For this one we can see that A is here, B is connected here. Okay, so A is connected there, A is connected there, B is connected there. Next we have another AND gate. Okay, therefore AND gate, that is called G3. Okay, what is the name that we have given for this one? There is no name is there, therefore let me write this one is T2 for example. Okay, similarly I'll write this is also, it is internal to the circuit. I better write in this green color so that it is visible. So that is called T3 for example. So therefore this is called T2. Now inputs for this one is B comma C. So it's not a problem that you write first A then B, then you first write C then B. It doesn't matter. Okay. So just it identifies that the gate has got one output, and it has got two inputs. That's it. Next we have to write another AND gate, that is called G4. We write the name of this gate is the output for this one is T3, as you can see there, and C comma A are the inputs for this one. That's it. Okay, another gate is also there, right? So finally we have to write G5 also. So G5 is R means small r. So don't write that A and end capital letters, that you should not write. Okay, this is also not acceptable. Okay, something like this. A and also is not acceptable. These are all not acceptable. So only acceptable keyword is A and end. That's it. Small letters all. Okay, if you anybody write like this, so it will be wrong. Okay, so please identify that issue. So or R is a keyword for the OR gate. It is G5. So what is the output for this one? C out is directly connected to the G5, right? Therefore C out. Next inputs are, as you know that, T1, T2, T3. Okay, so that's it. But one thing we have to write, T1, T2, T3 are internal to the circuit, right? So we have to mention those variables are also as some type of data type, so that the simulator will identify that yes, there is a variables are available there. Okay, so for that one I am going to use these variables. That variable is actually a wire. Wire we have to use internal to the circuit. Whatever the internal wires are there, those things are called wire data type. Okay, so those are all T1 comma T2 comma T3. So that's it. So is it clear to all of you how to write a Verilog program? So finally we have to write end module also. Don't forget to write this one. So end, don't give any kind of space, yes, end module. So this is how we have to write a Verilog program for the AND gate. Sorry, full adder. Is it clear to all of you? Is there any doubt regarding to how to write a gate level modeling for the circuit? So it's a very basics. So if you know these basics, then only you are able to write a program for any other complex circuits. Okay. So therefore, once if I am able to write this one, you can write any program, whether it is a, as you can see, it's a decoder, it's encoder, it's a multiplexer, it's a comparator, it doesn't matter. Once we have a gate level circuit, we have to write a gate level modeling in this way only. Okay. So if you have any doubt, please take 1 minute time and please ask me the doubt. If you have any doubt related to that.